For most of the machine learning problems, we can classify them to be two types, the supervised learning or unsupervised learning. Let's take a look at them in details. Supervised learning have labels. But no matter it is a numerical labels or categorical labels, we can train machine learning models with these labels. On the other hand, unsupervised learning looks for previously undetected patterns in the dataset with no pre-existing labels. This means that our final outputs might be any value, expected or unexpected. Well, pause this video for 2 minutes and think how to classify the 6 common used machine learning problems to be either supervised or unsupervised or both. Are you ready to know the answer? Let's unveil the black box together. For ranking problem, we have labels of the ranks. Classification has labels about the classes, and regression has labels about numerical outputs. And anomaly detection has labels of whether it is an anomaly or not. That's why they are all supervised learning. On the other hand, ranking, recommendation, and clustering all can be viewed as unsupervised learning if we use some clustering algorithm to calculate the similarity or group items together. Similarly, for anomaly detection, we can detect an outlier if its feature distribution is dramatically different from the vast amount of majorities. In this course, we will be mostly talking about supervised learning. And now, let's take a look at several examples of supervised learning and unsupervised learning. So, one example for regression is to predict the housing price. Given the feature of a house, such as how many bedrooms does it have, how large is it, and how old is it, then we can apply some multivariate regression techniques to output prediction values. And for a classification problem, here is a tool example, where we want to classify the stars versus the dots. So we label all the stars as 1 and all the dots as label. The feature here can be viewed as how many points on the star or a dot, how many edges does it have, and how large are they. Well, one interesting paper about the COVID-19 can be viewed as a clustering problem. It is a recent research paper about COVID-19 cases in Singapore. So each circle here represents a positive cases and reported date of these cases. So the pink circle here means there is a relationship to China, while the blue circle here means there's not. So how do we trace each case to say how the coronavirus was spread out within Singapore? We can using the unsupervised learning algorithm called clustering, which extract the common characteristics of the features and group the cases which are similar. And in this problem, the features are the locations where the patient visited. For example, the cluster at the lower left here was being labeled as the Grand Hyatt Singapore. This means all the affected cases here have been to the Grand Canyon Hotel and somehow got infected with each other. So there are definitely much more exciting machine learning problems, supervised or unsupervised, outside this class. Just be a curious observer, pay attention to detail, and develop a machine learning thinking during the daily life, and you will gradually gain the ability towards a machine learning expert.